Hello, this is Desmond Martin from NextWaveSTEM. So glad to be with you all here at LitCon. We're still waiting on a few people to join in with us, but we'll be excited to have you. To be had here. This has been a weird time, and I know that we don't have to belabor that point, but I'm really looking forward to discussing remediating learning loss through hands-on STEM with you all today. Just a little bit of a heads up, we are not in webinar mode today. This is a meeting, open forum for discussion. And if you've got any comments or questions, you're able to open up your microphone. I'm double checking my security settings. Yes, you're able to unmute yourself and or open up your microphone at any time to ask any of your questions. So if there's anything that you would like to know or want to dig into some more, we will be more than happy to do that through the course of our chat today. And I know we're just a few moments before the start, so we're going to give people just a little bit more time to join in with us. Another bit of housekeeping, of course, I'm sure that we're all Zoom experts at this time, is that if at any point you have any questions that you'd rather not open up your mic or your environment might be a little bit noisy, the chat and the Q&A function is turned on. So if you've got a question or comment or you just like to engage us that way, you are more than welcome to do so. I think we may have a few more people on the way, so we'll give this just a moment before we get started. I am going to ask a favor of the one participant that we have so far. You're going to get specialized one-on-one attention during the course of our talk. I'm just going to run a quick AV check. Can you hear me okay? And can you see the screen? You can jot something in the chat or just quick open your mic if that's easier for you. Okay. I think we are good. So we will go ahead and we will begin. Thank you so much for taking time out of your extremely busy days and schedules just to spend an hour with me. My name is Desmond Martin. I'm the Chief Learning Officer at NextWaveSTEM. I'll do a little bit more of a formal introduction in just a little bit, but I have the distinct pleasure of presenting our NextWaveSTEM topic today. Remediating learning loss through hands-on STEM. I'm really excited for this talk because we have the opportunity to think extremely creatively when we think about what hands-on STEM learning means for our students in this context. What context could you be talking about, Desmond? Don't leave us in suspense. Well, I think that the fact that we're on a Zoom right now instead of meeting in person says a lot about the overall context with which we are holding this talk this year. I will also note that this is NextWaveSTEM's first time at LitCon, so I would like to thank the LitCon organizers. We've had the opportunity to present once before at a tech talk for CPS, and we unfortunately know that tech talk was canceled last year as well as this year because of that. So any opportunity for us to come and speak with our school partners and with our potential partners is an amazing opportunity. Just one little bit of housekeeping, and I know I said this previously. The chat is open, so is the Q&A functionality. If you have any questions at any point and you need me to slow down, you need me to speed up or you would really love to dig into the subject matter, into the weeds a little bit more, that is completely fine. I am a big fan of spending as much or as little time on subjects as we'd like. Also, you are more than free just to open up your mic and jump in. I can't tell exactly who we have on our roster just based on the names that we're using in our Zoom handles, but that's not a big deal at all. If you've got any questions, I'd love to jump into the weeds with you. And with that being said, we'll go ahead and press right forward into it. I first like to talk a little bit about who we are at NextWaveSTEM. We are a almost 4-year-old ed tech startup based here in Chicago, Illinois, serving primarily CPS schools. We've worked with over 80 schools throughout the country thus far, as far south as Texas and out in California, Palm Springs, but much closer to home as well, Michigan City schools. And the vast majority of our partners are here in CPS. We are CPS born and bred. Our founder is CPS Central Office alum, and we take great pride in growing up and having broad shoulders here in Chicago. At our core, NextWaveSTEM, what we believe is that students need to be empowered to be our next generation of problem solvers. If I had to distill everything that we do at NextWaveSTEM into one sentence, it would be that. Students have to be empowered to be the next generation of problem solvers. And we understand there are many, many links in the chain. That is teachers, that's access to technology, that's access to resources, that's access to supplementation, that's access to social, emotional resources. But at NextWaveSTEM, we understand that it's critical that students have a STEM identity, that they know and believe in their hearts that science, technology, engineering, and mathematics are not fields that are completely beyond them, that they can actually engage and engage at an early level. We think and hold as a truth that kindergarten is not too young to be learning about robotics or about drones. We know that our 3rd graders and 4th graders can design and 3D print objects and can actually use them to solve problems. And we definitely believe that our high schoolers have the ability to learn some computer science and program artificial intelligence, to know what they're useful for, and to really consider their ethical usage. We're a hands-on STEM company. We know that getting hands-on with the technology, playing around with things, breaking things and fixing things eliminates that fear of failure. And so we empower not just our students towards that end, but our educators and our supplementers and library technicians and library professionals. I mentioned our core technologies just briefly, but at NextWaveSTEM, we do 2 things. We do them really well. The first is that we are licensing our curriculum. You can come in and buy the curricula in our technology areas, robots and artificial intelligence, drones with 3D printing, but we also partner with schools and organizations with respect to instruction. Our instructors will actually go into the school, will go into the library, will go into the community centers and run classes, both in person and virtually, as we have been throughout the course of the pandemic, and present these courses on emerging technologies. And these courses are aligned, NGS grade band, Common Core Math and ELA, and they also are supporting 21st century skills that we know are so critical. Not just the 4 C's, but also when we think about literacy skills with information and technology literacy, but also those leadership skills, the ability to communicate, the ability to respond to conflict and to change. Our courses are there and they're designed to help continuously support that. So now that we've talked a little bit about who we are and what we do, I want to focus on our main goal for today. Understanding learning loss in STEM, just giving some context. It's really, really interesting to be at this time where the discussions around learning loss previously were really, really prevalent because of that amount of time that our students would be spending away from the classroom, spending away from the library in the course of the summer. It's still extremely interesting in the kind of data that's coming in on the effects of learning loss amongst our students here in Chicago, but also nationally and globally, because we were dealing with a global phenomenon, are still coming in, but we've got some initial things that are worth talking about. The second thing we want to explore is the idea of using project-based learning and hands-on learning approaches to STEAM education. Sounds like there might be kind of a disparate and disconnect between those two ideas, but in actuality, they live together in concert. Just because our students are removed from the physical context of our libraries, of our schools, of our learning centers in our communities, doesn't mean that there aren't creative ways for us to continue to engage them with hands-on learning. A lot of us have been doing professional development for the past year around this idea of keeping our kids engaged, not just only in their core subject areas, but figuring, okay, how do we continue to do those things that oftentimes are thought of as extra through the course of the pandemic. We want to focus on the really huge pros of project-based learning towards that. And finally, we want to talk about some tactics for STEM remediation that go beyond our classroom and our face-to-face group time with our students. There are some tried and true things that we can do, things that we've learned really through the course of the pandemic that will allow us to remediate our students' experiences with STEM learning, and even think about the way that that supports their core subject area learning, whether that's in math, whether that's in English, or thinking even about their science. It is a critical thing for us to do, and we can get really creative and use emerging technologies to do that as well. So really excited for the chat. Once again, if you have questions, don't hesitate at all to let me know what they are. Okay, so the first thing that's really useful when we're trying to track a path where we want to go is understand our current location. GPS doesn't work if we can't know where we are on the face of the earth, and we can't figure out how we will want to remediate unless we have this idea of where we are in the current context of learning loss. We know it's very, very, very different than what we might have experienced traditionally, especially when there have been various and sundry types of learning disconnects and learning disruptions for our students. So let's contextualize some of that. Well, first off, let's consider data that we have on the math and science situation. And McKinsey really has done a really good job of taking some initial baseline estimates and understandings of where learning loss may stand for our students, especially given the context of their different disparate populations. We understand nationally that students who have not had a robust amount of live interaction with their teachers this fall, that those numbered and quantified amounts of learning loss really are stratified along socioeconomic lines and along racial lines as well. On average, nationally, we're talking about an equivalency of 12 full days of time that those students don't have. But if we break those out along racial lines, we're looking at, on average, white students having that learning loss at around 8 days, Black students having that learning loss at, on average, once again, around 15 days, and Hispanic students, Latinx students having that learning loss at around 16 days. This is kind of that vicious cycle and this truth that we've known for a while, right? That our communities that don't have the same level of resources, and that oftentimes does break down along racial and socioeconomic lines, are disproportionately impacted by loss. And that kind of falls back to this idea of access to resources. This is not completely bad news, mind you. We've seen things get better, and we've seen things accelerate and get better throughout the course of the pandemic. Where we were standing in May of last year, May of 2020, we saw reporting of around 79% of Black students saying that they had access to devices for learning through the course of COVID, and that number has jumped up to 89%. That's still lagging behind white student populations and Hispanic populations, but we're on an upward trend. And we're seeing those trends reflected also with respect to access to high-speed internet. This is not what we would like to see, mind you. And we know that the libraries have been tasked in various contexts to really help be remediators for this. But a multiplicity of different scenarios cause this to be an issue. Both social location, but also home learning and support infrastructure, things like high-speed internet, things like a quiet place to be able to learn and read and study. We understand that these are making significant impacts and having disparate effects on our students, just based on their zip code and their own situation. And what we've also seen is this idea of a new normal being established. The actual uncertainty of the pandemic, the uncertainty of what our students can expect with respect to returning to in-person learning, the uncertainty for even just the realities of COVID mean that we have all had to do some tremendous planning. We've all had to consider some what ifs and try to minimize harm and minimize loss, but also distribute some very, very powerful resources in a short amount of time. Most researchers don't think of this as the new normal, but think about this as the next normal. That we've seen this complete paradigm shift when we think about what students have access to with respect to their resources, especially with respect to hardware. We are moving into a paradigm where we already believe that access to high-speed internet and computing devices is really essential. We've seen that in Chromebook and PC and laptop distribution in the district and Chicago Public Schools for quite some time. I think now more than ever, we understand that is a critical must-have. We're going to see institutions and schools that did not have access to these resources and did not have this baked into their infrastructure, have this be baked into their infrastructure going forward. Whether this is Chromebooks, the distribution and checkout of internet hotspots, something that I know many librarians across the district have in their wheelhouse. And I should have put an asterisk next to this, but we can also think about the distribution of technology kits as well. Not just access to internet, not just a box to be able to open up your web browser and the actual data streaming through, but also thinking about that hands-on hard learning material, not just printouts, but actually what students will be interacting with in their technology courses and classes, whether that is robotics or any other kind of technology. That is an interesting paradigm shift that we've seen some schools have access to, but I think we're going to be seeing many more resources allocated towards. And that presents, once again, a very, very powerful opportunity when you think about what's going to happen in the coming school year and in years beyond. So we've got a couple of different paradigms that we could embrace, knowing that we're going to have resources coming because we're closing gaps to access and information and high quality instruction. And we also know that the way that those gaps are going to get closed is not also just monetary resources and instruction and professional development, but also hard and fast technology resources, be that Chromebooks, access to internet, or technology kits when we think about the STEM context. So we can kind of bottle our solutions, some things that we can do, into three ideas for what we can do as supporting staff and libraries to really help our students. And some of us are doing and considering and building some of these solutions right now. The first is this idea of the Acceleration Academy. And what we're thinking is of the intensified, really longitudinal learning that will expand over the course of the summer. We're talking about formatting, like week-long academies in reading, 25 additional hours of instructional time, and this targeted instruction, working in small groups, both virtually, but as it becomes available in person of 8 to 12 students, kind of that hardcore boot camp intensive learning. And this is just trying to put the money where our mouths are in a smart and efficient way. When we are looking at the price tag on this, it's something about $42 billion if we did this across the United States. And we're looking to reach half of the United States school-age children population. So there's a lot of flex, a lot of variability there. But that's one idea here that we know different districts and different states are playing with, and you may be experimenting and learning about as well. But another idea here is of a high intensity tutoring. This is much more longitudinal than the focused acceleration academy. We're thinking about support and growth of remediation over a year, even 2 years. And this is where our access to devices and technologies and kind of a reconfiguration of the way that we think about even the daily school day may be critical in remediating. You can imagine a format where we're seeing 50 minutes a day of tutoring in mathematics. A lot of this work is being done by our paraprofessionals in our school classrooms or even by our library technicians, assuming that we are actually increasing that number of resources. We may see really focused numbers and ratios of instructors to students. We may see even as low as 2 to 1 when we think about student to teacher ratio enabled for that high intensity tutoring to make sense. The price tag on that is higher. Of course, we know our students are worth it, but we also understand that that takes a massive amount of resources and require really deep systematic change. I would love it. I'm going to be honest, I would love for that kind of thing. But another option, a third option, is something that we already kind of have in our playbook when we think about STEM that's really been applied in the more core subject matter areas. And that's something that we can take advantage of now and for really, really low amounts of money compared to our other options. And that's in project-based learning. We can absolutely flip our entire paradigm around project-based learning when we think about integrating immersion technologies, and we think about what it will take to make those technologies available to our students over time. And the great thing about project-based learning is that good project-based learning experience design is, one, inherently longitudinal, but in our current context can be hyper longitudinal. We can get 1 or 2 years of additional learning focusing on emerging technologies and supporting our other core learning areas through good project design in the distribution, really intentional, really targeted distribution of physical resources. So you want to talk about what that looks like. So what is hands-on project-based learning, and what is that looking like in this situation where you as a library technician and support staff, or even an instructor, are going to be providing that for your students? What do we talk about when we mean hands-on project-based learning? At NextWaveSTEM, that's part and parcel, it's core in what we do, and that becomes critical to build our students' understanding and help them remediate losses. Well, the first thing that's really useful is to actually establish and kind of lock in what we think about as a project-based learning instructional model. What are the core tenets here? The first, and we'll dig into this a little bit, is the driving question. This idea that as our students are learning, their learning is really centered around the ability for them to choose a question to answer or a problem to fix. And the great thing about that is not only are we empowering student voice and choice, which is so important in building investment in student learning, but we are also giving us the ability, for lack of a better word, to give our students all kinds of rabbit holes to climb down. Our students will dig in and climb down and be involved with and love the questions that they actually care about. And depending on the level of answering that they're able to do, depending on the level of inquiry and research, depending on the design and the feedback, depending on our student events, things that we'll dig into a little bit, depending on how we engage our communities and what it means to present that solution to the question or to the problem to our school communities and to the community at large, that will really dictate how deep we get. And as an aside, we can even think about empowering our students further. Community involvement also means building project-based learning models that not only are solving problems and allowing our students to grow, but are actual real-world solutions. We're not kind of putting our kids at the kiddie table anymore. We're actually engaging them and giving them stakes in their learning through project-based learning methodologies. So when we think about a project-based learning unit, what we see here is kind of this track that goes through this really nice virtuous cycle of project launch, something that's really teacher driven, and then into the student driven work that honestly goes into this really amazing tree of different decisions for what students can do to engage the learning material, but also to solve these problems. So everything you see here highlighted in blue, and we'll return to the slide. Everything that you see highlighted here in blue is student-driven and student-led work. Our jobs as instructors becomes to, one, be proficient in all these different types of work and really give the accessible rubric and the standards for which this work rises in all of these different scenarios, one. But two, becomes to help guide our students, not really lay out the path, but guide them with different options of paths that they can take with regards to the learning that they're doing in their project work. So we launch a project, and then we give our students options for how they want to attack the project. Some of them may want to do the lecture first. They may want to figure out a way to gobble up information about something that's interesting to them. Some of them won't care about that at all, and we just want to get hands-on first with lab work, or they'll want to jump on Wikipedia or use Google or any other tool to start doing their research. It's really up to them. But then we benchmark that. We give the accessible rubric for whatever path they're going down. It may look different from student to student or group of students to group of students, but we give them those options and we benchmark and we give the feedback and reflection that helps guide that next work. We shouldn't think necessarily of these student-driven activities as being things that can't be returned to either. This is really variable. We may see workshops and lectures and homework in our second round or our third round or our fourth round or our fifth round of our project-based learning. But the idea is still the same. We are turning the work over to the students to continue to grow towards a solution. We're using our rubrics to benchmark that work. We are then providing that individualized guided feedback and recommendations of what that next student activity or options of student activities might be. And then we're allowing our students to drive that work forward, continuing to cycle back and continue to help our students refine and get closer to their answer and to their final presentation and to their final solution. It becomes one in which our students are really able to own their learning processes. Now, super duper important to this, I know I kind of was exuberant in the way I emphasized this earlier, is this idea of choosing the driving question. Nothing, and I do mean nothing from this point on will go really the way that we want it to, unless this is a driving question that our students actually care about and are invested in learning about and solving. And this, for lack of better words, is something that we cannot patronize our students about either. With respect to what they want to learn, to what they're interested in, this is something that should affect them. That is local or state or national or even international. There's no such thing as having this be too small, because we're going to spend a lot of time and be able to drill down into the good questions that we're asking and to the answers that we're getting. So what we should be in real time considering for our students is what is a problem that currently exists. It's a problem right now. We're not solving a problem that's been solved before in a different context. We want something that's real, that's active. What tools are really available for them to be able to solve those problems? That's resources, that's access to social capital. That's also, once again, our hard and fast technology resources. And how can we ensure that, especially when we're solving a problem, this is a real solution? When we present these solutions, when our students present these solutions, how can we make sure that this is something that's tested and actually works? If our driving question that our students come up with and want to pursue is how can we land a human being on Mars, we understand that that's a real question. It's timely. There's reasons why you want to do it. We understand the tools that we may or may not have available to that, but there's a pretty high likelihood that we won't have the ability to actually test whether or not we solve that problem and who we're actually solving that problem for. So that's where we have to tailor. We have to actually dig into some facets of that problem that's actually solvable and testable with our students. The goal here is not to leave them on a cliff in speculation, but to really actually give them something that allows them to know whether or not their project work, their solution work actually works, and what they can do to get closer to that solution in the future. So we've kind of built out this structure. The project based learning experience is really driven from the beginning in partnership with instructor, with support staff, with the driving question that builds into the student-led work that they're getting benchmarked on, they're getting feedback on to be able to be driven to the next part. How do we attack that work? What does that look like? What's the actual event? What's the work that's getting done? Where's the money being made here? How's the sausage being made? Well, this is where I want to focus on in particular, technology. We want to talk about making technologies that are engaging and exciting and available to our students that allow them to answer these problems in real and tangible ways. And a great technology, my favorite technology actually here at NextWaveSTEM to be able to do this with is with 3D printing, for a bunch of different reasons that align with our goals as support staff for library staff teaching literacy across multiple domains, but also give our students the ability to diversify their skills and integrate a bunch of different disciplines at the same time. So when we work with 3D printing, we're teaching computer-aided design principles, which is really interesting. It might not pop off at the very top of your head here, but our students are going to need to know how to design objects and processes in 3 dimensions in order to be able to actually participate with 3D printing in an effective way. I'll actually briefly dig into that a little bit more in a little bit. But when we're working with 3D printing, we're also natively engaging engineering principles and processes as well. In the context of STEM, that big acronym, we've got science, technology, engineering, and mathematics. Engineering is special. And it's special because by nature of all of the letters in the acronym, engineering is the only discipline that is explicitly human focused. Humans conduct science, and we can even go as far as to get pretty metaphysical and philosophical and thinking about math as its own type of science as well. Humans are able to create technology, but technology in and of itself, generally speaking, not always, but generally speaking is neutral. Technology is neither good nor bad. We think about its application and what kind of impacts that has on our environment, on other people, on the entire world around us. When we think about what engineering is specifically solving problems using science, technology, and mathematics. We're saying when we do engineering that there's something that needs to change, that there's something that needs to be done better, that there's something that needs to be done faster, and that there are reasons why we want to do those things. When we do engineering, we are actually making a value statement. We engage in the engineering process because we're saying that we're trying to solve a problem. There's something wrong. There's something that we're improving, that we're trying to make better. Our other disciplines don't inherently say that at all. So we have this special activity, this special work that we do when we're engineering, because in the work that we're doing, whether we're conscious of it or not, we're actually making those value statements. The students are 3D printing, and I know that's kind of heady stuff there, but it's critical for our students to understand that. When students are 3D printing, when we're talking about the nitty gritty of what this looks like, we're engaging our technology resources for cloud-based design. Their Chromebooks or their laptops or even their iPads are things that they can use to do 3D design. They are not going to be constricted and restricted to the computer lab at the school. They're engaging in the engineering design process. So throughout the course of that entire life cycle of a project-based learning, we're returning to those student-driven activities. We are going to be going through those step processes, whether it's 5 or 7 or 12 steps of the engineering design process where we're able to iterate on the design. They're going to go through the same thing. And the great thing here, and I'm not going to spend very much time on, but when we think about 3D printing, the nature of the 3D printing industry is such that not everyone has to have a physical 3D printer to be able to engage in 3D printing. If that 3D printer is with you living in your library, you're not just a library with a 3D printer in it, you are also potentially a 3D printing service. That is a service that is servicing potentially multiple classrooms in your school. That's a service that is potentially servicing multiple individual students in your school. That is potentially a service that is serving multiple community partners around your school and who engage in your school community. The only reason it's not that is honestly for a lack of understanding and sometimes capacity. I'm not saying that every single student in your school needs to print at least one object per year. That's not what I'm saying at all. And if you've only got 1 or even 2 3D printers, that may not be feasible. But it's not, however, unfeasible to have multiple classes of students regularly using your 3D printer in your school remotely and not actually having to physically touch the printer. That is the kind of situation where just a little bit of learning and understanding of how to manage project and workflow makes our life really, really simple. And that's the kind of thing where we don't cover that in great detail in this webinar. I'd love to get into the details with anyone who wants to dig into it some more. Basically, this boils down to this idea that we can connect to a physical printer. We can go through this process of slicing and printing, and a lot of this work is going to be done remotely with our students. A lot of this work is going to be done by our staff supporting our students, and we're going to be iterating through that entire process, getting our students involved as we go. So it's useful to think about then physically how a 3D printer works. If I'm saying that we can do 3D printing remotely, we have to understand what this machine is and what it does. You may be extremely familiar with how a 3D printer works. You're basically thinking about a hot glue gun on a robotic arm that's laying down individual layers of material over time. And what we think about then is a technology that's extremely variable. It's also useful to think about the comparisons that we can make, very, very useful comparisons that we can make in between a 3D printer and a more traditional ink printer. If you've got a school that requires literally tens of thousands of printed documents, what you've done and what we've done for decades is two things. Created the capacity. We have enough machines that can meet the demand for the printing that we do at our school. But then we also understand the processes. Our printer is not printing 5 minutes before we need to print documents. We make sure that we're printing in plenty of time ahead of time. We understand how long our print jobs are going to take. We make sure that we're prepared ahead of time and we structure our time accordingly. It's much, much more convenient when we understand that if I need hundreds of documents printed, that I can maybe start that job on a Friday and come back and get my printed documents and I'm ready to go on that Monday. And the same kind of idea, yeah, it really applies to 3D printing as well. Not at that large scale, but it also applies. Something that I alluded to as well when we think about our student activity and engagement in project-based learning with 3D printing technology is actually understanding the process. And to understand that 3D printing is just not the printer working, but it's everything that builds up to the printer working. So it's really 3 steps. We first design. We are giving our students the tools to either from scratch design 3-dimensional objects, or we're empowering them with the ability to download for free, of course, 3-dimensional objects and modify them. It's a both and kind of situation. And when we think about design, we can almost liken that akin to word processing. As our students learn to write and then as they learn to type, they're generating these documents, they're generating, especially in the visual space, these file formats. And the same thing is true when we think about 3D printing. As they grow in their 3D spatial acuity, if they grow in their ability to use the tool, they're generating these file formats that can be emailed, that can be uploaded to our Google Classroom, that can be shared via the platform, and that can be 3D printed. That will get better. They'll look like the pieces from Monopoly at first, and then you'll get these complex, beautiful 3D design pieces that are solving problems. But the second part of this process is the process by which our students start to translate just the math into where the math meets the science a little bit in slicing. An analogy that I make is that 3D printers are like automobiles. Doesn't matter if you're driving a monster truck, doesn't matter if you're driving a Honda Civic, doesn't matter if you're driving our Mercedes. These vehicles, by and large, do the same thing pretty much the same way. They all are taking some kind of fuel into the vehicle. They all are translating that fuel through chemical energy into motion. And whether that's getting there at 50 miles an hour or 100 miles an hour, whether it's got the ability to climb over rocks, they all generally have some kind of steering wheel or 4 wheels and get you from point A to point B. They're different, extremely different, but they are getting you to the same place, doing the same thing, fulfilling the same function. Our 3D printers are very much the same way. They come in different sizes. They have different features. They can print at different temperatures. They run at different speeds. And some of them will be using different software. However, we can take that raw mathematical file and print that file on any printer. It might be different sizes. They might come out of different qualities. But regardless, if your students change schools and both schools have a 3D printer, there's no reason why that file that they designed in 3rd grade at one school cannot grow and change and live with them to be printed out later on, multiple times later on at another school in the 7th grade, and then again at another school in high school. This is the kind of thing that continues to live and can grow with our students over a large longitudinal spectrum. And third, we talked a little bit about is physically transforming the design into the print. And this really can become your wheelhouse before it becomes your student's wheelhouse. This is the future of computer manufacturing. There are pretty much no fields where people physically make things anymore, where at some point in the process, a 3D printer was not involved. We're talking about prototyping. We're talking about architecture. We're talking about robotics. We're talking about athletics. We're talking about going to space. These fields, or future fields and future solutions, are going to rely heavily on 3D printing and the process and all the different niches of workers that are going to fill in each step of these processes. So I want to come back to this slide and really focus on the student-led work, the student-driven work here. The idea that in those 3 phases, those 3 modalities of designing, slicing, and printing, we also have, multiplied by all that, these modalities of our student-led work. And this is not exhaustive. These are 18 different types of student-led work, whether that's actually running the printer and building something, or if it's getting feedback on the building process, or if it's building a 3-dimensional model, or if it's modeling in a different kind of dynamic for our students. All these things multiplied by 3 are the different types of student experiences that we might have, and that's just keeping it extremely surface level. We understand that there's a huge variability and plenty of time and a lot of work that we can do to get some robust learning done with our students. So lots of talk, lots of theory. What's a real tangible, tactical approach that we can begin with? If our students don't get something printed right away, what's hands-on, what's available to them right now, they can get them started before we were talking about distributing kits or making sure that our students have Chromebooks with adequate Wi-Fi connectivity to be able to engage in something like 3D printing or any other immersion technology. Where will we get started? Oh, I'll start with an example, actually. And a performance example, something that we talk a lot about here at NextWaveSTEM is making the learning real, giving something tangible to our students, and engaging and plugging them in while also demonstrating a plethora of skills acquisition that allows them to really participate. In this performance example here, we want to answer this question of how can we use some simple design skills to model a building in real life? And the logical follow-up question was, okay, are we going to pick any random building, or do we want to do something that would actually potentially be very interesting to either ourselves or our students? This also gets into this deeper question of how do we create experiences that really root our students and give them the ability to feel connected to the places where they live? How do they build ownership in the spaces in which they live? Part of that is their ability to articulate what those spaces mean to them and how they see those spaces, and then be able to express that articulation, whether that's in writing or mathematics, or in this case, 3-dimensional design. So the example that I use all the time is the Sears Tower. Quick confession, I'm not originally from Chicago, I'm from Detroit, and I grew up learning that it was called the Sears Tower, and I've heard in the 3 years that I've been here in Chicago, that it's also known as the Willis Tower, but the Sears Tower it is, and Sears Tower shall remain. Our students can actually model something like a Sears Tower using basic design skills. And this might not be a thing that they do on day 1, but it could honestly be the thing that they are doing by day 2 or day 3 using basic skills inside of our design software. We'll use Tinkercad. It's really simple. And I'll actually flip over to it right now so that we can see what's going on. This is something that our students can dig into right now. It's free. Many of the students in the district have already used Tinkercad in some kind of context with respect to 3D design and 3D printing. Many of you may have used Tinkercad before or are actively using Tinkercad. Something like a Sears Tower is a great design to dig into because for as complex and as iconic as it looks, it's actually a really simple design. The designer, the architect, the original architect, Mies van der Rohe, actually didn't do 1 tower, but he did 9. It's a bundled structure, a bundled tube of towers. And there are 9 towers that are laid out on a 3x3 grid. So we can take basic shapes because the Sears Tower really is just a bunch of right angles, honestly. We can take some basic shapes and align them and create a 3x3 grid in really quick succession. And this would be just a very basic demonstration of what this looks like. Our students will learn how to drag and drop shapes. Our students will learn how to modify shapes. Our students will learn how to align shapes and rotate the view and really become familiar with a tool like Tinkercad. Flipping back over to my presentation, the cool thing about the Sears Tower is that I mentioned before, oh, I think I left out my little diagram, or maybe I did. I mentioned before, yes, here we go. Our Sears Tower is a bundled structure here, going up different floors corresponding to different towers. There were at least 2 towers. Every tower in the Sears Tower has at least 1 twin that goes up to its height. So our towers on the adjacent sides here go up to a height of 50. Not digging into the weeds so much here about what's going on, because if you are familiar with Tinkercad, you kind of get this idea of designing and using units and making sure that we are putting the right units in for our different measurements to be precise inside of Tinkercad. We've got 2 other towers that jump up to 66. For as many times as I've done this demonstration, it's probably a good idea at some point if I memorize these measurements. We've got 3 more towers that go up to 90. And unless my memory fails, I know our central towers are going to jump up to 106. So in the last 3 minutes, we've done some pretty robust design. We've added multiple shapes. We've changed those shapes, not 160, 109. We've changed those shapes and we have arranged those shapes in such a way inside of our digital design software, in this case, Tinkercad, that we've got something that kind of looks like the Sears Tower, not quite, but with a few more transformations. If I group all of our shapes together, Tinkercad just needs a second to do a little bit of math. And then we adjust dimensions at the bottom, make everything nice and square. We have got a beautiful model that looks like something we can easily recognize down there right off the lake. And this is a model that would 3D print off of a 3D printer in about 35 to 40 minutes, depending on our printer and depending on our settings. This kind of engagement, learning how to use the tool, learning about the design of the Sears Tower and why it's designed the way that it is, and then being able to design this in 3-dimensional modeling is not beyond our student at all. And it's coming from this space of design that's really, really simple, rooting our students in space. That's something that our students can do right now with their Chromebooks and access the internet connection. We just need to build and scaffold and find the right driving question that takes them to that place pretty quickly and pretty effectively. And we can expand. You think about a tool like Tinkercad or 3D printing or 3D design for only 3D manufacturing, but we're able to make resources available that don't correspond to a 3D printer. We can design a model or import a model, in this case, the lunar lander module here, and use Tinkercad to mock things up in Minecraft, if our students play and love Minecraft, or even give instructions for how to build representations in Lego bricks. Many of our students love and play with and engage with Lego bricks, and Lego bricks may be something we have as a resource for our library as well. So all of this comes together in this idea of being flexible in a distance learning or hybrid or in-person instructional model. We're really familiar with this idea of being able to shift in between these student events that are both led in person and remotely. And depending on our situation, those logistics look different, but we're making sure that in project-based learning, because we have these events that can happen both at home and remotely, we're not breaking down here. We're not painting ourselves into a corner. We're able to shift and respond to our students' needs accordingly just by shifting our logistics. So I keep coming back to the slide, this idea of student-led work. What my hope is that we can really embrace the opportunity to parse out where our students are able to take the equipment that they have and then build upon and augment with emerging technologies. The example that we showed today really lives in the space of 3D printing, but it doesn't have to live in the space of 3D printing. It also has this real ability to reflect other technologies. This can be done with your robotics club. This could be done learning how to fly drones. This could be done with computer science and learning to use AI. This can be done with learning about ecology and farming and growing plants. This can be done when we think about exploring English and language arts. If we're exploring history, thinking about physical national artifacts. We shouldn't get boxed in here, but we should think about ways in which we are working with our staff, working with our instructors, thinking about our instructional goals and even our assessment goals, and really building together in a longitudinal way. Where the secret sauce really lies here is this ability to bring everything together, to integrate together, and then really target this expansion of equipment to allow this to happen for our students over a long amount of time. That is a super, super exciting opportunity that we see at NextWaveSTEM, and we're hopeful for our students for the future. And in everything we do, we want to make sure that we're engaging our students, exploring, giving the opportunity to explain and elaborate, and then coming back to our evaluation. So lots of hopefully useful information, lots for us to think about and digest. I would be remiss if I didn't mention how we at NextWaveSTEM have been helping and are able to help, especially when we think about project-based learning and introductions to emerging technologies going into the future. First is, I mentioned up at the top that we do offer our emerging technology courses. Each of our courses are designed to help our grade band students really get introduced to emerging technology if they are new, and if they aren't new, if they've got experience with our particular emerging technology, take that learning to the next level, connecting it to solving problems, and then eventually moving into careers. At the K2 level, we're dealing with robots and drones. At the 3-5 level, we expand a little bit where we're doing an introductory robotics drones course and then a 3D design course. In our 6-8 level, we are exploring robotics a bit more, connecting to actual industry uses and career opportunities. The same is happening with our drone as we're growing in our computer science skills, since those drones are being flown autonomously. And then at the 3D course, we're engaging the engineering design process more and more. 9 through 12, I'm really excited about our artificial intelligence course, where we have this opportunity now to change the mindset around artificial intelligence, where our students aren't just the consumers of the tech, and in some situations where their data are actually being turned into products, instead they can be the creators for this kind of technology, and they can apply the technology to solve problems while really ethically considering the impacts of these emerging technologies. This work, and if I could raise a big red flag and draw a giant asterisk over a field, it would be this field. This may really, in some critical ways, guide the future of not just education, but of our society and humanity in general. In the Jones course, we are actually simulating and solving problems, thinking about real and hard and fast applications of drone technology. And then our 3D printing course, we're actually designing and iterating. We're closing the design loop when we think about the engineering design process and actually teaching our students how to redesign based on feedback. That is an incredible opportunity for us. I kind of mentioned this, that we are doing a natural progression of knowledge when we think about the taxonomical buildup of knowledge acquisition, but also the ability to synthesize and produce solutions with that knowledge, much unlike what we talked about when we engage with project-based learning. And we try to be an all-in-one solution for schools and organizational partners. That's our full lessons in our courses, 10 to 15, depending on your course, along with 6 lessons that are perfectly designed for virtual, equipment for your classrooms, and then also professional development, training, and support around this. If you attend NextWaveSTEM training, those are ISB certified PD hours as well, and we're there to support you through implementation. But we can also work to customize what you need for your school. So if you're looking to expand into a new emerging technology, you want to explore things like green screens, for example, that's something that we're really excited about building into in the future as well. And one thing that I know I mentioned just briefly is that we also do instruction. We have a stable of instructors here at NextWaveSTEM that have been working with NextWaveSTEM partner schools and CPS partner schools for the last 3 years, both during school and out of school time. If you feel like you don't have the time, you don't have the resources, the bandwidth, or the expertise, our certified instructors can step in and really fulfill the bill. They've been doing that for the last year now remotely, and we're going to be coming back to doing what we love and getting into the classroom. So I've run down the hour here. I've been yapping and running my mouth and covering so much content. I know we're right at time. So I, at the very least, wanted to give us a couple of seconds, maybe 15 or 30 seconds as I peer at the clock to entertain any questions. If you've got any questions, there are only a couple of us here. We can open your microphones up if you've got a question, or you can throw your question in the Q&A or the chat. Any of those is completely fine.
Yes, I'm just wanted to know, is there any website where you can get this literature where I can kind of dig in deep and kind of look into that? You can put in the chat that I can.
Absolutely. And that's actually the very next slide. We are, oh no, that's not a problem at all. That's a great question. That lets me know that you've got a nice and organized mind like mine. NextWaveSTEM.com. And you can also email me. I'm Desmond Martin, once again, Chief Learning Officer at NextWaveSTEM. My email address is really simple, Desmond@NextWaveSTEM.com. And you can find us on all major social media networks. That is Twitter, LinkedIn, Instagram, and Facebook. No TikTok. I have a really bad dad joke that I usually make here about not taking and talking, but I'm going to leave that off since we are a little bit over time as it stands right now. If you've got any questions or you just want to dig into more material, you can reach out to us at the website or directly to me in email. I can connect you with the School Partnership Manager.
Thanks a lot, Desmond. Great session. Really interesting.
Absolutely. Thank you so much for just taking a little bit of time with us. We hope that you enjoy the rest of LitCon. This session is going to be running again in a little bit. So tell your friends if they want us to go by, we would love to have them. But until then, you all be safe and we will be talking with you soon.
All right. Have a great weekend. Thank you.
All right. Bye-bye.